So, hello everybody, good morning. I cannot exaggerate in how heartwarming it is to see all of you here today. I'm talking about our guests, governors from overseas at this very difficult hour for us, and your presence here physically is empowering. We can use all positive adjectives in the context of your physical presence here. It's really heartwarming to see you here. So this symposium is about This symposium is about technology and engineering and security and war, and let me separate those a little bit. So we are living through an era of extreme change. Everything about us is changing everywhere, almost everything and almost everywhere. Society is changing, our children are changing, we are changing, the way we interact with each other is changing, the way we get to know each other is changing. Everything is very different. And some of these changes are good, some of these changes are bad, some of these changes we don't know yet if they're good or bad, but they're usually very scary. And whatever they are, for Tel Aviv University and for Israel in general, change is not a question of good or bad or scary. Adapting to it and directing it in the correct direction is a matter of survival. Harnessing it and working with it, it's a matter of our survival, and we have no other way but to pursue this change and to engage in working on it. Now, most of this change, almost all of this change, essentially is driven by science and technology. And when we talk about technology, our faculty of engineering primarily is engaged in engineering and technology. There are other faculties in life sciences, medicine, and exact sciences. They all contribute to this joint effort of technology, and this is what we are here for today. The other part of the title talks about security. Originally, it had the title of the faculty's contribution to the war effort. And this is a part of the title that I must say that I was less comfortable with, simply for the reason that our opponents overseas take advantage of titles like these to promote boycott of Tel Aviv University and of Israeli universities in general. I want to put this in context. Perhaps we haven't chosen the correct title in print, the one that went out in print. This one is a better version. We're talking about security, not about the war. But I want to put these things in context. The war is a war that the state of Israel is fighting against Hamas, not against the Palestinian people. It is fighting this war against Hamas. And the ones who are fighting this war is the Israeli Defense Forces and other security forces and agencies, and Tel Aviv is not one of them. Tel Aviv University is not a security agency. It is not an agency of the government even. It is a university. But with that said, we must remember that we, the people of Tel Aviv University, I'm talking about faculty, administrative staff, and students, we are citizens of this country, and we are immersed in this war as individuals, as parents to IDF soldiers, as some of us are reservists, our students are reservists, we're teachers to students who go to the military, and we are immersed in this thing. We cannot disconnect ourselves from this. This is one part of the story. The other part of the story that as you know, we value academic freedom and we enjoy full academic, I should say perhaps we still enjoy full academic freedom. And there's a ranking of academic freedom in universities in the world, and Tel Aviv University is right at the top, all Israeli universities, right at the top of this list, above the United States, for example, in that index, above the Netherlands, above the United Kingdom. It's interesting, I was surprised to see that, but this is the situation. And valuing academic freedom as we are, we don't tell our faculty what to study. And it is only natural that many of our faculty choose to study subjects that are related to Israel's security and that contribute to the various, or that respond to the various calls that are published by security agencies or by the IDF and other entities. And this technology that we engage in the Faculty of Engineering, but also in other faculties, is meant to help make the efforts, the security efforts, the war efforts of the security agencies and of the IDF more effective and more precise, and by that to save lives, to save the lives of our own children who are in the military, and to save lives of innocent Palestinians, to make the act of war less damaging and reduce collateral damage. And personally, I'm proud of that, and I'm proud of this connection and of this relation. And I think that, that this is the context in which the title of this symposium should be interpreted. Now, at this point, I think that what remains is only to wish us all a very enjoyable and successful symposium, and pass the microphone to our guest here, Udi Galun. And he's from the R&D parts of the IDF. Please.
Thank you, Mark. Thank you and good morning. I'm excited being here. My name is Udi Galun, and I'm from the Ministry of Defense. I'll say a few words what we are doing together, and there's a lot, and some of that you will see this morning. Thank you, Noam, for Professor Noam Elias, for inviting me here. Along the years and the time, we're doing beautiful things together. Some of them, I believe that you will see. From my personal perspective here, I'm a graduate of Tel Aviv University, I'm proud about being that. But not only that, actually I started, if I may say, my career related to the Tel Aviv University as a child. My mother was a professor, my late mother was a professor in Tel Aviv University, a biologist, professor and a dean of students. So she was not only my mother, she was mothers of others around here. And as a child, I remember being at the Six-Day War. It was not here, it was in Abu Kabir. That was the place where the university was before. And during the war, there was a kind of a shelter there that, I was going with her to the university then. And there was a small shelter, it's an old building, our building, and in the basement, it was a Professor Mendelssohn. He was a professor of biology. Huh? Sorry? What is your mother's name? Margalit Galun. And so in this basement, there were, he stored the snakes. He was a zoologist. And so he told us, if there is anything, you should go to the basement. Of course, he didn't want to go to the basements. But she said, and he was a yeka, you know, he said, those snakes will protect you. Okay. So maybe it's something to think about, to use. Nevertheless, there's a lot of work on the zoology that we are doing. Professor Ayali is doing us very nice things and as well. And my personal perspective, I'm a scholar lecturer, proud of being giving a course in optical materials here as well. So it's a kind of a continuous, very close relations with myself. I'm head of the materials division at the DDR&D, which is the main R&D activity at the Ministry of Defense, but not only the Ministry of Defense, it's all around the security developments that are being in Israel related to us. And on behalf of myself and the head of our organization, Dr. Danny Gold, he was invited to give his talk here. He's now an official mission to the US, so he's apologizing for not being here, but sends his wishes for you and for us to go on. And Dr. Nadav Cohen, the head of the S&T unit where I'm working. So yeah, I'm very much excited. We are doing ongoing many studies with the universities. I believe it's more than 100 maybe all over the university. Yes, mainly at the engineering department, but it goes ongoing from biology to all different studies. Maybe 3 things. One is developing special bandages for wounds, which is something which is important very much, and doing some nanotechnology detectors that we're very much into them. Many things. As the war started in October, maybe one of the first telephones we got was from engineering, from Noam, and said that there is quite a few suggestions, quite a few demands to go and to work together. So we started, and then we established this war room that you will see and hear about many things. Nevertheless, it's not only myself, but working with Noam. Noam is very much related to the Air Force. And if you go actually to the Air Force depot in Tel Nof, it's one of the main Air Force bases, maybe the biggest one that we have. And you go to the corridor, you'll see at the corridor all the papers that Noam along the history and actually now is publishing with those people. So this is, I think, very important to realize that high-level science and research is being held at the researchers at the depot. So this is, I think, very much exciting. And not only this, quite a few students coming from there to here. So this contact with the Air Force, and not only the Air Force, is rather very important for us. For the future, they said there's a clock, but I'll finish soon. For the future, maybe things go on with what you do, and I'm very excited in doing it. I think we would like to have more excellent students programs together with the Faculty of Engineering and University. It's something which is very important. And please go on and to do this special programs. We need some new ones. And beside that, it's not only research and study, but it's infrastructures and labs. And now we are going on to establish a new infrastructure, I hope with Tel Aviv University, maybe with your support, of advanced manufacturing. This is what we start with 3D printing, but we want to go above it. So this is something that we're looking forward. And thank you very much. Thank you, Noam.
Welcome everyone, and thank you for joining us this morning. Shortly after October 7th massacre and the launch of the Iron Swords War, I was approached by the Israel Ministry of Defense. They wanted our Faculty of Engineering to set up a war room to harness our capabilities and solve real-time battlefield engineering problems. They chose Tel Aviv University because they knew of our innovative spirit, cooperative culture, familiarity with their needs, and dozens of our projects that they already funded. We quickly established the war room and started working on over 20 solutions in communications, weaponry, surveillance, and more. To date, about 70 Tel Aviv University professors, technical staff, and students have been engaged in the war effort. You will shortly hear about our amazing engineers, professors, technical staff, and students, and how they have worked side by side with combat soldiers to tailor solutions for the myriad problems being faced on the battlefield. I'm so proud of them. They have led the remarkably swift development of new technologies that both improve our soldiers' capabilities and save lives. I can say that every day, for sure, we have dozens of IDF soldiers that are, their lives are being saved due to the technologies that we developed here, and this is really important. I hope that by the end of this session, you will all equally proud, be equally proud and excited about the endeavors. Sadly, we cannot present all of our projects in this session. Some are too complex to describe here, while others are highly classified, and if I told you about them, I would have to kill you. However, I will say a few brief words about them. First, immediate solutions to battle problems. Our task force focused on providing an immediate response to several defensive problems. This included rocket threats from Gaza, subterranean challenges, ceramic vests, suicide drone testing and training, and more. It was led by researchers from the School of Electrical Engineering and the Department of Biomedical Engineering, together with colleagues from the School of Chemistry and with the guidance of a tech team from the defense industry. It resulted in an incredible abundance of novel ideas, many of which turned out to have great potential and were chosen for field implementation. Notably, whenever a solution of ours became operational and helped save lives, our sense of accomplishment was immense, far beyond the usual successes we experience in our daily academic lives. Solutions for booby traps. One of the biggest challenges faced by soldiers on the battlefield is booby traps. These traps, typically comprising explosives, are set to detonate upon touch, nearby movement, or remote activation. They turn everyday objects, such as doors, stones, or beds, into death traps. Several projects being advanced by our war room addressed this threat, and our faculty members worked around the clock to develop solutions. Due to the complexity and sensitivity of these efforts, I'm unable to divulge specific details. However, I can say that many lives were spared as a result of these innovative solutions. Drone training. Drones have become a key part of modern urban battlefields experience. During the first weeks of the war, combat units were in urgent need of training on drone threats. One of the drone pilot instructors was our own Dr. Tomer Bachar from the School of Mechanical Engineering, who also piloted drones himself as a reservist. Thousands of soldiers received the training before they entered Gaza, learning how to identify drones, locate them using acoustic and thermal means, intercept them, and more. Crucially, following the training, no more drone injuries among IDF forces in Gaza were reported. In addition to drone threats, the instructors group also ran an accelerated practical training course, both for military and civilian personnel, specifically for operating a new type of thermal drone which no one in Israel was yet familiar with. As a result, we helped increase drone efficiency, which is very helpful for locating terrorists and reduce drone losses due to GPS disruptions. At around $10,000 per drone, you can imagine the major importance of this achievement. Development of a special long-range remote controller car. In wartime, IDF soldiers must deal with numerous dangers, including foreign objects in tactical areas. Swift identification of such objects is crucial for preventing harm to the soldiers, and the remote control system is required to detect and identify them. In Gaza, soldiers use remote-controlled vehicles equipped with cameras to identify potential threats. However, communication problems often occur between the operators and the vehicles due to rocks, bushes, and other obstacles affecting the reception range. To address this, Professor Pavel Ginsburg and his team from the School of Electrical Engineering have developed a system to increase the control range of a unique remote-control car that can overcome difficult terrain. Using more efficient reception channels, the system enables the user to wear special glasses that show what the car's camera sees. It thus provides a sterile, safe, and convenient method for identifying foreign objects. The system is already in use by combat soldiers. 3D printing of adapters for military radios. Since the beginning of the war, there has been a shortage of mechanical adapters for radio communications. With the help of our engineering students, we redesigned the 3D model of such adapters and formed the manufacturing group. We then brought together students and researchers from several labs, as well as from private companies, to 3D print hundreds of adapters per week. Representatives from many infantry units visited our faculty to collect the printed batches. I don't have time today to show you some examples of really soldiers leaving the Gaza Strip, coming to Tel Aviv University, commanders, picking up boxes, and then immediately returning to Gaza. It was such dramatic. That concludes my summary of the projects that we could not present to you today. I cannot conclude without noting that Israel is under war and that we won't rest until all hostages are back home. On this occasion, it should also be noted that our Faculty of Engineering has had more students and professors conducting reserve duty than any other faculty in Israel, even more than the Technion itself. In addition, under the leadership of Professor Aryeh Yerdor, my vice dean for teaching and students, we were among Israel's leaders in offering generous study accommodations to students performing reserve duty. Now, my talented colleagues will present 4 fascinating projects to give you a small taste of our exciting contribution to the war effort. I'm delighted to invite Dr. Avishai Sintov from the School of Mechanical Engineering.
Hello, I'm delighted to be here. I'm Dr. Avishai Sintov, head of the robotics lab at the School of Mechanical Engineering. When I was a soldier more than 20 years ago, I could only dream of robots assisting in the battlefield. It's not. Okay. Okay. Apologies for the delay. So today, more than ever, this dream is a reality. Robots are now an important tactical tool for IDF soldiers in the battlefield. Drones and mobile robots are available even in squad and platoon levels. They are used to inspecting uncharted regions, gathering intelligence, and offense. In all applications, they protect the lives of those soldiers. While these robots are changing the battlefield, they are not autonomous. During combat, in dangerous environments, the soldiers operate them using remote controllers. By doing so, the soldiers are observing their surroundings for potential dangers. They are not observing their surroundings. They release hold of their weapons and not ready to respond. In an aggressive and hectic environment, the soldier must control a robot, process events in the area, and most importantly, stay safe. this leads to a high cognitive overload, not an easy task for anyone. As part of the Human-Robot Interaction Consortium funded by the Israel Innovation Authority, we have been collaborating with Elbit Systems, a leading defense technology company. We aim to enable robots to understand natural intentions of humans and act accordingly. With simple gesturing of the soldier, along with some verbal instructions, the robot will understand the required task, very similar to how humans interact. First, we developed the leech unit. The leech can be attached to any robotic platforms, including various sensors and strong processing unit to run our models and algorithms. With cameras, the robot can recognize intentions and commands of nearby soldiers. Here are a few examples. One challenge is for the robot to recognize the occurrence of pointing exhibited by a soldier, estimate its direction, and move to the implied target. A unique model we developed enables accurate and robust estimation of pointing direction using a simple camera. Here is my PhD student. Not gonna work? Oh, it's working. Here's my PhD student, Eran Bamani, demonstrating pointing in natural human-robot interaction. With the model, the robot can instantly recognize pointing and move to the required goal position. Therefore, a soldier can direct a robot to some target with just a simple gesture, naturally. No, back. No. Okay, so another challenge. State-of-the-art in gesture recognition does not allow an effective distance range of more than a few meters, a range which is not practical for commanding robots in the battlefield. Also, they enable recognition only indoors. We developed an algorithm for recognizing gestures in long distances of up to 30 meters in indoor and outdoor environments. Here are a few demonstrations in different environments. With this technology, a soldier can easily direct a robot to approach or move forward a target from long distance and even from within a trench. These models are already being integrated into robotic platforms used by the IDF. I would like to invite Inbar Meir and Eran Bamani to demonstrate this in real life. And of course, Bruno the robot. What's that? In ongoing work, we are adding verbal understanding such that a robot can receive more information about the required task, along with the gesture. For example, a pointing gesture can accompany an instruction to search a house. No. Our developments lead the way toward a different battlefield with less endangerment of soldiers and easy interaction with robots. While giving autonomous and AI capabilities to robots, we must always remember that some decisions in the battlefield are to be left to human intelligence. I would like to give credit to my talented team at the Robotics Lab, Eran Bamani, Inbar Meir, Eden Nissenman, and Lisa Koenigsberg. And of course, Bruno, Thank you for your attention.
It's difficult to talk after Bruno, so challenging. So next, I'm delighted to invite Mr. Roy Reich from the School of Electrical Engineering.
Hello, I'm Roy Reich from the School of Electrical Engineering in Tel Aviv University. Following the events of October 7th, a command center, or as we call it, the Hamal, was initiated in the Faculty of Engineering in order to assist the war efforts. As part of this initiative, a connection was made with different IDF units in order to aid and help solve real IDF needs from the battlefield and as soon as possible. I would like to present some of these solutions developed in the School of Electrical Engineering and in the School of Mechanical Engineering. The first project I'm going to present is an electronic tester for a USB charger for IDF tanks. What we saw here are tanks maneuvering in the Gaza Strip during combat. One of the main challenges the Army encounters is the inability to recharge tactical mobile devices in the battlefield. As these tanks were designed before USB charging sockets were made available inside the tanks. The solution is this charging adapter. It connects here to the socket in the tank, and here they have the USB sockets in order to charge the mobile devices. Before we can connect this USB charger to the tank, this equipment must go through a series of rigorous testings in order to prevent any issues, as this device will connect to a tactical outlet inside the tank. The tank core made contact with the School of Electrical Engineering and asked for a quality solution for this test as soon as possible. We, the engineers of the school, immediately saw the importance and urgency of sending these USB chargers to the battlefield. Thus, we designed and developed and delivered the electronic tester in a few days. So this is the electronic tester, and it connects to the socket. And basically, hundreds of these units that we saw previously, the adapters, were tested using this adapter and were already sent into the battlefield. Here we can see the entire system connected as we test with our tester one of these adapters.
Hello, everybody. My name is Yosef Kandiat.
We will now see the solution presented by Yosef from the tank core.
Hello, everybody. My name is Yosef Kandiat Ishneor, and I'm from Unit 363 of the tank core. What I want to show you today is the new Maten Lior. The Maten Lior is basically a charger for the tank, the charger for phones in the tank. On one side is the entrance of the tank, which is inaccessible for us, and on the other side we built a double USB port where we can charge our phones. It's very, very important to us as tank people. We don't have a place to charge our phone. When we're in Gaza, we cannot use our phone. We use a special army phone that we need to charge it. I want to show you the connection of the Lior charger into the tank. Here's the tank. Here's our connection. We put it in here very simply. On the other side, like I said, a double USB port. We stick in the USB, any USB, and we have our phone, and we can just charge it. So simple, so useful, and there's really no other solution. Thank you so much.
What we can see here is an official letter on behalf of the IDF Armed Forces that approves our solution of the electronic tester for the USB charger. And on the bottom, they're stating, your presented solution is better than all other solutions tested so far. The next project I'm going to present is a night vision camera for the IDF. This video shows an armed terrorist penetrating through the border fence at night as observed by the military tactical night vision equipment. This equipment is not available to all soldiers because of budget limitations. The IDF made contact with the School of Electrical Engineering and asked for an inexpensive and accessible solution for a night vision camera for soldiers in the field. We, the engineers of the school, saw the immediate need, thus we designed, developed, and delivered the night vision camera in a few days. What you can see here is the mobile phone connected to the IR camera, and inside the phone, the mobile app is running the software. Okay, we can see here. We will now see a demonstration video of our solution. Okay, we can see here that we are almost in complete darkness and we can barely see Simcha approaching us. And now using our device, we can see how we can clearly see him approaching us. And now we can see in color that when we turn on the lights, and we can see how we can see Simcha is waving at us. Thank you. Another demonstration video of our solution is shown here side by side, as we can see the comparison of the daylight vision versus our solution. The last project I'm going to present is a live video stream for Israel Border Police tactical dogs. The motivation for this project was inspired by a very unfortunate case where if only the IDF had access to live video stream of the tactical dog camera, lives would have been saved.
אני מבקש לעדכן את הציבור בבשורה קשה וכואבת. במהלך הקרבות בסג'איה, כוח צה"ל זיהה בשוגג 3 ישראלים חטופים כאיום. כתוצאה מכך, הכוח ירה לעברם והם נהרגו.
לוחמי סיירת גולני הגיעו למתחם וניהלו חילופי ירי עם מחבלי החמאס מבלי לדעת שהם מחזיקים ב3 החטופים. במהלך הקרב נשלח כלב של יחידת עוקץ למבנה כשמצלמת גופרו על גופו. הכלב נהרג מאש של מחבלים, אבל המצלמה המשיכה להקליט כל הזמן. עוד שהתגלו רק אחרי שהחטופים נהרגו מאש צה"ל.
עשינו! חטופים על הקרקע! עשינו! אנחנו ברעננות!
This is indeed a devastating tragedy. This tragedy driven us to come up with a solution. Here we can see the tactical dog with a camera solution attached to the harness on its back. Unfortunately, not all tactical dog units have access to a camera solution, let alone a live video stream solution of the dog due to budget limitations. After the Israel Border Police made contact with the School of Mechanical Engineering for a solution, our solution contained 2 stages. The first part of our solution was to harness an inexpensive and fast-to-deploy cameras to the tactical dogs. The School of Mechanical Engineering immediately heeded the call and designed, developed, and delivered a dog harness camera in a few days. In the next video, we will see a training footage of the Israel Border Police using this solution.
כלב נשלח!
The second part of our solution was to develop an inexpensive live stream cameras to the tactical dogs. The School of Electrical Engineering decided to design and develop a radio communication setup live stream camera. So you can see here, this is the screen that the operator can see from a distance, a live stream of the camera that is sitting on the harness on the back of the dog. The setup has already passed preliminary testing with the Israel Border Police and is soon to be delivered. In this video, we can see a footage recorded with our setup in the testing phase. This footage is a live stream video that is live streamed to the dog operator holding the portable screen outside of the building. Next, I would like to welcome Itai and Idan to say a few words.
זה עובד? אז ככה, בוקר טוב לכולם, תודה רבה לכם. אני רוצה להודות דבר ראשון לפקולטה, להנדסה, לאורן, לדני, לארקדי, לשמחה, לאירועי. רוצה להודות לכם באמת על הרתמות. אם לא אמרתי, אני איתי מיחידת הכלבנים של מג"ב. בתחילת המלחמה ההנדסה נרתמה פה, האוניברסיטה לעזור לנו פה בפיתוח של ציוד שעזרו לנו בפעילויות. ואני מאוד מאוד רוצה להודות על זה. תודה רבה, זה עוזר לנו מאוד בשטח. שיהיה לכם יום מצוין.
To summarize, I've shown you today just a few examples of the project we were working on for the military. Usually, the university is more focused around research. However, when a certain need has risen, we quickly helped in producing immediate solutions for the battlefield. We are certain that our solutions have saved and are saving Israel soldiers' lives in the battlefield as we speak. Thank you.
And this is just a snapshot. Next, we'll show you something that is not related to the war and battlefield. We want to think about the future, something in the really cutting edge of technology in the world. As you may know, there is some race between Russia, China, United States. We are like a small country, and I'm very honored and privileged that the U.S. Air Force, the research lab, the USAFRL, chose Tel Aviv University as, to the best of our knowledge, the only partner outside the U.S. in this spatial project. They sent us some greeting from the U.S.
My name is Dr. Phil Buskell, and I am a senior research engineer in the Materials and Manufacturing Directorate of the United States Air Force Research Laboratory. Our research mission is focused on the discovery of novel materials and processing methods to enhance the operational capability of our airmen and impact enterprise-wide affordability. Additive manufacturing methods, such as 3D printing, are an important part of this strategy, and as they offer significant advantages in customization, local control of material properties, the realization of complex geometries, and reduced lead times over conventional techniques. We are not alone in this view of the exciting potential for additive manufacturing. For example, 3D printing and advanced materials are 2 of 12 potentially economically disruptive technologies, according to McKinsey Global Institute, a report that is widely adapted around the globe by both industry and academia. The Faculty of Engineering at Tel Aviv University also have this vision for additive manufacturing and are making it a reality through their world-class research in polymeric and metal additive manufacturing research and development. Based on the technical strength and innovation of additive manufacturing of Tel Aviv University researchers and other Israeli institutions, we initiated a 6-year, $4.5 million partnership agreement with the Israeli Ministry of Defense to accelerate the development of additive manufacturing materials, printing processes, and design tools. We are particularly excited by the directed energy deposition capability of Tel Aviv University's Additive Manufacturing Center, which has enabled novel solutions to metal and ceramic coatings, part repair, and functionally graded prints. To the Faculty of Engineering, I commend you for your thought leadership in this area, and thank you for your partnership with the Air Force Research Laboratory to innovate the future. Thank you.
Hello, my name is Vladimir Apostol, and I am a materials research scientist at the United States Air Force Research Laboratory. My background is materials for extreme environments, and more specifically composite materials for high-speed aerial platforms. In terms of ferrothermal durability, carbon, ceramics, and their composite variations are the standard preferred candidates. But what makes them so durable also makes them very difficult to fabricate using traditional manufacturing approaches, which is where our collaboration with Professor Elias and his team comes into play. Utilizing directed energy deposition, or DED, which is a variation of 3D printing, his team is exploring the deposition of ultra-high temperature ceramics on refractory composites which our laboratory has manufactured. The effort is unique in a number of ways. One is that DED is traditionally a metallic forming technique, but Professor Elias's team is using it to melt and deposit non-metallic ceramic materials with melting temperatures in excess of 3000 degrees Celsius. A second is to evaluate materials compatibility in previously unexplored material space. Extreme temperature differences, often more than 2000 degrees Celsius, between the ceramic melt and the composite substrate can lead to large thermostructural shocks impacting the integrity of the coating substrate system. A third advantage of DED is its ability to apply these coatings to complex geometries which more adequately represent realistic flight platform surfaces. Even if partially successful, this effort can provide a novel approach to the advanced manufacturing of materials for extreme environments, while at the same time providing an improved scientific understanding of the underlying thermostructural phenomena. A separate, but I think just as insightful note, different R&D organizations do things differently, and when they do this for a long enough time, they tend to get stuck in their own way of doing things. So it's great if every once in a while we get a chance to see how others operate in the same space, and maybe learn something which we've done differently at our end can improve our own processes. This collaboration has been one such opportunity to give us a chance to appreciate a different perspective on materials development while establishing a strong collaborative relationship. Thank you.
So I personally want to thank the US Air Force for getting the clearance so quickly and willing to send it. So before concluding this part, I would like to welcome to the stage our engineers, researchers that led some of the developments. Please join me. Come on, guys, standing ovation. They really deserve it. They are working 24/7 voluntarily just for real Zionism, you know, and wish to save lives. So I really, really appreciate it. All of us, you deserve it.